radius offset. Okay, then I'm gonna have to get that critical point, right? Okay, so it's gonna be the one at you. It's gonna be like self at you. Gotta get center. So at V that gets center. Minus self at U get center. Alright, this is a vector pointing towards V from U. Then I want this scaled by the radius of U. So I'm gonna have to normalize this first, which I'm pretty sure I can do with space ops. .pi. Pretty sure there's something to normalize here. What is fallback? If norm is greater than 0, then it does that else. Okay, that's interesting. So let me just import space ops if that's not already here. So this is within mobject. So I'm going dot utils. Import normalize. I think this is actually already imported. Actually, I don't think that's true. Alright, so let's do that. I'm gonna normalize this. Then multiply it by the U radius. Maybe I should just yeah, I'll just call it self at U dot radius. Okay, I'm gonna see if that just doesn't crash right now. Great. So that's going to V from U. It's scaled by U's radius. So now it's like this U center plus U radius offset. I'm gonna do the same thing for V. So this is pointing at U from V. I'll scale it by V's radius. Okay, so with luck, this won't overlap the nodes. But we don't have luck, so it doesn't work. Okay. Replace with this with a V. Well, it didn't fail, but it didn't work either. Yeah, I'm not sure why that happened. Maybe this update edges did that. If I don't add this updater, I wonder if that'll do it. It does, great. And I think that looks a lot better before it moves. So here's what I'm gonna do. In update edges, pretty much just going to do this again. For U comma V. Let me make this VU vector. Actually UV vector. This be V minus U. So this. And normalize that. I could just have this times u radius, and then negative. I could just have this times u radius, and then negative this. Times the v radius. Maybe I don't even need these variables now. I'm gonna do it. I'm sacrificing clear code for pretty much nothing, for fewer lines. Okay, I'm gonna make sure that's the same thing. And it's not. Wait, did I break this or... Wait, let me remove this updater. Alright, so I didn't break that. What I have to do though is do the same thing in this updater. So let's just do the same thing. Compute this vector from u to v. I think this is from u to v. Yeah, this is from u to v. Normalized, and then edge dot put start and end on. And I guess this is starting with u. Plus lines obscure code, I would do the exact same thing. Okay, so the thing is, this isn't super obscure, right? Right? Yeah, I think this isn't too terribly obscure. But yeah, that's pretty much what ends up happening. Tell myself the same things. Yeah, okay. Yeah, future me is gonna come back and be like, dude, what in the world? There's a lot of places in this code base where there's just like these insane list comprehensions or whatever that just don't make sense to anybody. Because this was written by someone who didn't expect it to be used by other people. And it is painful sometimes. Okay, let's see if that works out. Nice. Okay, so that has it offsetted by the dot radius. And now, gonna remove that. And now if I were to increase that radius, say here, that looks pretty much the same. I don't know if I increased it. Great. I think this looks a little nicer. I think they're maybe too big in this case. But in general, I think this is going to look a little nicer than having them go to the middle. Okay, so the thing to do now is actually make a graph that looks like this. Which I don't think should be terribly difficult. But I do think I'll have to figure out how this library does it. Or this API, rather. Um, 1 through 8, then you can just... I guess if I add the nodes and the edges and the connections between them, it'll lay them out correctly. Although there is a way to position them manually. Okay, so for now, I'm just going to copy over this graph. What's going on with my voice? Jeez. Verbatim. I'm just going to copy over this graph. What's going on with my voice? Jeez. Verbatim. Let me quit that and go here. I'll close that window. I think. There. And I'll just number each of these. And then do the connections between them. So the number of dots is 10. So let's just make this. First, I'm going to see if I can make this range. No, I'm not going to bother with range. I'm just going to put 5, 6, 7. I'll just do that. Then if I number these like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then firstly, I have the connection between each odd number and the even number that follows it. So I just add those connections. So I have 1, 2, 3, 4. This will be 5, 7, 9. This would be like this. Perfect. I wonder if Network X... I'm sure there's a way that Network X can offset those radii enough that they don't overlap like that. But I'm not going to look into it now. Probably later on. I mean, there is a way to manually position them. What is LT though? Oh, layout. That's a pretty bad name. But okay, then if this is 1, 2, then this is 3, 4. This is between each odd number and the next odd number. So 1 and 3, 3 and 5, 5 and 7, 7 and 9, and 9 and 1. Okay. So then I've done all of these, done all of those, then these. This is each even number. And then 2 even numbers later. Each even number, and then 2 even numbers later. So this will be 2 to 4. No, not 4, but 6. And that'll be one for 2, 4, 6, 8, and 10. So 4, 6, 8, and 10. And this is plus 4, this is plus 4. This will be plus 4. This will be plus 4, but then I have to wrap around. So this will be 2, I think. I think this is 4. Great. Oh no, that graph looks kind of equivalent, I guess. Kind of. A little bit. Kind of, sort of. Graph isomorphism, I'm pretty sure is NP hard. So I guess it makes sense that it looks nothing like the original graph. But I'm going to have to add a manual layout to this. That or maybe network X. Maybe there's a way to pass network X the radius. Node size depends on node degree. Return the radius of the graph. Return the radius of the graph. Let's see. We got G and positions and arrows and styles and sizes. Yeah, I don't see anything about the radius. Oh well. I'll just position these manually right now. So the way this will work is have a dictionary layout. It's going to map each node to a position. Okay. So I think what I want to do is say for I in range 10, I mod 2 equals 0. Do one thing. Else I'll do a different thing. Then let me see what happens if I actually pass this empty dictionary to the layout of the graph. I think this will probably break everything. Let's just make sure. Yeah, I guess that just breaks it. So I won't pass that in yet. And right here, what I want to do, it's going to be a vector. It's going to be right rotated. Take the right vector, rotate it. So rotate vector. Like tau divided by 5 times I. It's not actually I, it's like the floor of I. Or the floor of I mod 2. Or I think the ceiling actually. Because for 1, I want it to go to 1. For 2, I want it to go to 1. For 3, I want it to go to 2. Although I'll have to reverse it. So I'll say index equals the ceiling of I divided by 2. And I'll actually just print those. Make sure they're what I expect them to be. 0, then 2 ones. Why did it? Oh, this is starting from 0. It should be 1, 10 plus 1. Okay. So then the start. This is tau divided by 4. So I'm going to start it here. This index is going to range from 0 to 5, 1 to 5, I guess. So I do that minus 1. Now it'll be 0 to 4. I'm going to start it at tau over 4. I'm going to check if it's odd or even. And that's going to determine a scaling factor. So I'll say in this case it's 3. And in this case it's 1. And so I'll say in this case it's 3. And in this case it's 1. And the vector layout indexed at I is going to be rotate vector right by start angle minus tau over 5 times index. Then I'll multiply that by scale, and I think that's what I want. I think. So this should be starting here, tau over 4. It's going to determine a scale based on whether it's odd or even. My homies use tau, yeah. It makes it way easier when I'm doing these circle things. Then from here, I'm going to rotate it by tau over 5 times that index and then scale it. Okay. Pretty sure this won't work. But you gotta start somewhere. Let's try that. Operands cannot be broadcast together. Don't know what that means. Wait, where did that happen? Move to self.layout index at v. Okay, so something's up with these vectors. Oh, you know what it might be? And these aren't NumPy arrays, they're just lists. Though I don't think that should matter. So I'll say layout at I equals that. Then I'm just gonna print the layout dictionary afterward. All right, this makes perfect sense, I think. Wait, does it? No, some of these have more than 3 entries. This one has 3 entries. This one has a bunch of entries. How did that happen? Rotate vector. Rotate vector must not do what I think it does. Yeah. So we put a breakpoint there. Step into this. Yeah, it would use quaternions. This is 0, 1, 0, so that's correct, I think. Let's go to the next one. The angle is just some angle. That's also correct. Step into this one. That's also correct. That's also correct. Okay, so why is that happening? I'm gonna print layout at I after I do each of these, then print layout at the end. Oh, and not pause here. Yeah, it's something with like 7 entries. Oh, it's only every other one is really long. For some reason, it's like doubled. So I guess it's when scale equals 1 or something like that. I guess it's when scale equals 1 or something like that. Man, I have no idea. This is another instance where it kind of sucks that this was written by someone who wasn't planning for it to be used by anyone else. Because I don't know quaternions. Okay, I'm gonna run it here. And the rotate function uses quaternions. So that's correct. And the next time I do this, 2, okay. Scale is 3. Wait, that makes no sense. How did that happen? Layout at I. It must be when I multiply it by scale. Oh. Because this thing is returning a list. It isn't returning a NumPy array. So I have to do NumPy array this. And maybe now. Great, I did it. The only thing is, it looks like these are the other way around. Great. Now if I don't add whatever, I don't do the animation, I can just interact with it immediately. And I feel like this should be a 2 or something. Cool. I did it. So next I'm going to have to 3-color this, which won't be hard at all. But I'm not going to do it myself, so... Is there a picture of this? Great, I can just use that. Although, that would mean... I want a different color depending on the node number. Probably isn't that hard. That probably isn't hard at all, actually. I'll just do for I in g dot vertices. G index dot I dot node color. Because I don't want to color it yet. Will be... Oh, I have to copy these, so there's no loop. I just have to do like at 1. So it'll be logo red. 4, 5, 6, 7, 8, 9, 10. Oh, 5. This is red, blue, blue, red, green, red, red, blue, blue, red, green, red, red, green, and then blue, green. Now I think... Now let me go through all of these. I in range 1, 10 plus 1. I'll do g at I dot set style. Fill color equals their node color. I think that that'll color it the same as the picture on the side. That is not red. That is definitely not red. But it did work. That should be more like orange. Okay. Alright, I managed to do that. It's been just over 2 hours, so I'm gonna stop the stream here. And thank everyone for watching.